2004, Marcelo, the shifting owner that's here, found us. We went to São José do Rio Preto for the first time. So I've been working with them since 2004. And we are really, really very happy that we have this kind of partner that stick with us, believe us, and we work really together since these 20 years. So that's why I'm here. And I'm here to introduce Adriano. He's the Product and Technology Director, and Higor, the Head of Architecture and DevOps. What they are going to talk about, it's not me, fortunately, is what they have been doing since last 10 years to unlock the value of the data. So they have many clients. They're going to talk about a little bit about the Shift company. And they have lots of data. How to change that and give value information to the end user, their clients. And of course, the end user, the patient, is benefited because the information is there. So how to change, how to unlock, how to governance data into information, useful information, not only information. So I'd like to ask Adriano to come, and it's your time. Thank you.
Thank you, Rochelle. Thank you for the great introduction regarding our company. At Shift, we provide the software for diagnostic medicine, which is a platform that includes LIS, RIS, and anatomic pathology. And our customers using our solutions impact in Brazil in over 500 million tests processes per year, which represent more than 20% of the national volume of processed tests in Brazil. We have a very differentiated customers in Brazil, and 85% of our customers have at least one quality accreditation or certification. And we crossed the boundaries, and now we are in 5 countries in Latin America. Before we dig into our strategy for data platform, let's take an overview on healthcare systems. We will always have demand for healthcare systems and its service. By the aging population, or the high prevalence of chronic disease, or use for preventive care, for instance. But we have a big challenge in healthcare systems. How can we extract the data to a single source of truth to sustain and to predict outcomes in healthcare? So, facing these challenges in healthcare, we create our data platform, which is built to sustain our products and deliver value to our customers. So, when we designed our strategic vision, we'd like to provide new opportunities to the market. And from the part of Shift, we want to keep and stay relevant for our customers and for the market. And we want to provide a benchmarking among our customers, which was our Impact Award winner last year in 2024. We also want to provide and generate sectoral data to impact the whole market in Brazil. And this platform to be a base to evolve our products, such as our Shift BI, to connect with external data and improving the decision from the part of the laboratory, and provide the commercialization of a new product such as data as a service, and the last but not least, to provide AI powered suggestion using AI to predict information. Now I'm going to share the stage with Higor, which will share with you the architecture vision for the data platform. Please, Higor.
Thank you, Adriano. Thank you, Rafael. So my mission here, or the architect mission here, is to lay eyes on the strategic vision and highlight whatever are the architectural requirements or quality attributes that the systems have to be or have to have in order to ground in technology the business vision. For example, real data and data monitoring demands performance. Data as a service demands compatibility and flexibility of access. So you can see that you have to provide information, a lot of connectors, and it's compressed in one single word of the business vision. AI and benchmarking demands trustworthy data and governed data and interoperability. So these three examples shows the work that the architect must do. But how do we enable this? So how we ground these business visions on technologies that we already have or need to have? Before I dive into the details of the project, let me give you an overview of how we do software architecture at Shift, which gets into foundations in the lean mindset, where we intend to always do the Kaizen evolutions, simple and baby steps. This way you will be able to understand the choices that we made, because I'm going to show not much details of the choices and all of the options that we've analyzed, because there's not such time. Well, in our architectural process, usually we start with understanding the target architecture. That means visualizing the future state we wanted to achieve. That reflects the long-term vision of how the architecture should look like, in order to meet business goals like technical scalability, operational efficiency, security, and innovation. And then, at second step, we need a clear once we have the clear target, we define the baseline architecture. Sometimes in the books or blogs, you will see that you should start with the baseline. It's an option. We choose this way because we want to see the target first and build a clear vision. And this represents the baseline. It represents how things work today. It includes the current systems, the technology, the integrations that we already have, constraints. Mostly constraints is an important thing to consider, and sometimes even technical debt. Without understanding the baseline, it's impossible to plan meaningful change, because we wouldn't know what we've been evolving from. While the target architecture has no limitation of the present, it would be built if we wouldn't have any constraints. But we also align with the company's strategic direction. But in the real world, we can't jump directly from the baseline to the target. Business needs don't want wait to perfect architectures, and neither does the market. So no architect will ever jump or make a leap from the baseline to the target so easy. Nobody will, pay the bill. And that's why there's the step 3. That's the concept of the minimum viable architecture, or MVA. That follows the same mindset of MVP, the minimum viable product. The minimum viable product goes like as it's a version of the product with just enough features, right? So you can go to the market, collect feedback, learn from that, and evolve quickly. The MVA is kind of different. It's a small set of technical choices and decisions that are tested and improved over time. So not always you will have the MVP and the MVA side by side. Sometimes the MVA will be larger, slightly larger, or sometimes less than MVP. But it's enough, just enough architecture to work. And sometimes that's viable architecturally, just what the MVP needs. But it means no shortcuts that would cause no major rework, but also no over-engineering. It's about finding that sweet spot between the baseline and the target architecture. From the MVA, we design what we call the transition architectures. They are intermediate stages between the MVA and the target architecture. Each transition architecture is a stable step designed to bring incremental value while moving closer to the target. So this is the way that we do software architecture at Shift. It's about progressive evolution, adding capabilities, technical capabilities, replacing legacy components, improving scalability, or enabling new features, step by step, without causing disruption, or intending to not cause disruption. But as you can imagine, defining this architecture isn't just about drawing diagrams. Each choice we make comes with trade-offs. And architecture is about that, right? If you ask whatever GPT that you have in your phone, you ask it to complete the phrase, software architecture is about trade-offs. It should reply this way. And, well, it's the trade-off between the complexity, speed, cost, scalability, and risks. It's easy to create software architecture, even with this process, and get it wrong if you don't use the proper tools. Well, the trade-offs, that's the key tool for defining software architecture. And that's exactly what I'm going to explore next. During the process, every architectural decision is based on clear requirements, no guesses. Always high-level requirements, but no guesses, no assumptions. We evaluate trade-offs carefully, and using lessons learned from the past, we also document everything using ADRs. ADR stands for Architectural Decision Records. It seems that will slow you down, but it's steps that you need to do. An ADR captured the important architectural decision made at a certain point in time. And point in time is the key here, because 5 years from now, somebody will ask, even yourself, you will ask, why did I make that choice? Or somebody in your team will not be there, and you'll be asking yourself, why did we make that choice? And the ADR is a small document, a small template that you should always use. It captures what was decided, what options was analyzed, what options was discarded, and the consequences of that choice. So you must do whatever it takes to register as quickly as possible, with more information than you have, to make the architecture reliable and resilient over time. This is the resilience of the architecture for the enterprise or the corporate point of view. You document. Meaning that every decision is made by evaluating each option while also considering architecture requirements and trade-offs between them. So architecture requirements, if you remember, when you analyze the strategic vision and highlights the requirements or highlights the quality attributes, you need to extract some things like performance and security, everybody knows. But you should consider a lot of more, like maintainability, interoperability, it's also easy, everybody knows also, but observability, reliability, and for some cases, not always, but for some cases, you have more than one requirement like AI or machine learning, like precision and accuracy. Well, in the trade-off, classic example of trade-off is when you have the highest, if you want the highest security requirement, then you will get the lower performance. But in another dimension, if you also need to choose between two components, the one with the highest security will win from the one with better performance, always. So trade-offs, what I mean is that trade-offs comes in dimensions, and you make choices all the time, balancing the both. And you always should, let's say you have 8 architecture requirements. You have to make trade-offs one by one between them as quickly as possible in order to get it right and don't damage the architecture that you are trying to build. And that's always with the goal of maintaining the software as the MVP, as reliable as possible. By doing architecture with that mindset, we get discipline and traceability without losing agility, or the ability to adapt quickly to the market. And now let me walk you through the architectural decision we've made for this project. I'm really excited to tell you this story I'm proud of. It's a history of 2 teams, the business intelligence and the architects. But again, I'm not gonna get into too much details because it's not much time to analyze every decision. So I choose to tell you just what you need to come out today. And this is our data pipeline in its phases. We have the collect, then the ingest, the store, the transformation layer, or step, or phase, the analytics, and the consume. With the highlighted words, and following the pipeline flow, you can see that there's a pattern that reveals that we did choose an ELT kind of data pipeline, not a traditional ETL, because if you had to transform the data as soon as it comes into the data platform, we would use more processing time. And if you're targeting the cloud, processing is expensive and storage is cheaper. And this way, we can use more storage and less processing time. We can be faster ingestion. Sorry. We can use different tools for each phase. We can scale independently from fine-grained tuning. And we also can fork new phases like machine learning under transformation phase. So you don't need to create a pipeline that is linear. You can fork new phases. This kind of pipeline gives you flexibility and less coupling. Well, the first challenge of the collect phase was to define the language to build whatever would send the data from the transactional systems into the pipeline. And we evaluated various languages and platform combinations to build a data collection agent. So we decided to build an agent, and that's because of the coupling. And the decision was to continue using the InterSystems object script, the COS. That way, the team could guarantee deployability across customer environments using our existing delivery mechanisms. This way, we enabled the launch of the MVP with 100% certainty that whatever our BI team would create will always, with certainty, work from the first time. The next challenge of the collect phase still was to define how to move data from transactional systems to the data platform. By transactional systems, I mean our own product, but not only. We could also include third-party partners and other vendors. When choosing between streaming data for a real-time processing was a requirement, or batch or a micro-batch, we could use 3 options, but as first option, we choose micro-batch. Because with that, because almost all data is relevant for a fixed period of time. Usually the need is answer questions like, how was our operation yesterday or this morning? But of course, there will be, like the requirement asked, real-time data. For that, we define streaming data only for that use case that's actually needed. So you don't need to choose only one way to collect the data. We carefully define an agent for that, tailored it to run only when we wanted, how we wanted, and for how long we wanted. Why that? Because with that goal, the goal was to not interfere on the performance of the transactional systems. Imagine that you have all the operation of the medicine center, and you have one more tool collecting and sending data to another instance. So the main constraint that we had there, it was to not harm the performance of the production environment. Well, the ingest phase challenge was to ensure a fast, scalable, and resilient ingestion flow, decoupled from the source systems. We faced the need to receive large volumes of data, regardless of the client's restrictions, without operational overhead. So again, this is a data as a service, as the strategic vision showed it to us. So it's a platform, software as a service running in one instance, or running in one place, right? And imagine that all those customers that Adriano just showed us, that volume of data hitting this one platform. That's why the ingest phase challenge was to ensure for scalable, resilient ingestion. Well, for that we adopted a REST API for zipped files. And we choose to zip inside that, the zip file, a CSV compressed file because, I know there's XML, JSON, and a lot of other formats. But the compression, we made a POC, and the compression ratio for the CSV was down to 73%. So imagine a bar, and you have the CSV file not compressed. If you compress, it goes down to the 73% of the original time. The size. With JSON, I don't know why, but JSON compresses only down to 84%. So we choose CSV. But not only. CSV also have an opportunity and a good thing that's almost every database can load, and Iris, of course, has it, can load a CSV directly into the database. And the landing, so another choice that we had to do is do or not do inline validation. So as soon as let me use the sticker. As soon as the data hits the ingestion phase, we would like to release this connection as soon as possible. So we choose to make the ingestion area act like a landing area, returning the 200 GP status with no validation. We only place there an endpoint protection, and this way we can support high throughput. In the store phase, we had options like trigger a service as soon as the file lands by another HTTP request, so an internal HTTP could be triggered from the ingestion to the store phase, or create a monitor with different technologies, even with the operational system. But we choose to monitor the landing area for new files using the iris interoperability connectors and load them in raw format asynchronously. So the platform works like this. It's like this is a spinning wheel and this is another spinning wheel. They are not coupled in a way that one depends on another synchronously. They are asynchronous. And with that, we have clear separation between the ingestion and the store phase. We had modularity, reliability, because the nature of iris interoperability, cost efficiency, by not introducing another component to our technology stack, and not increasing the customer cost also. And enable transformation retries, which we will handle this in the next step. The platform needed a transformation tool also, so because of that, the transformation phase. And also, we had to read the raw data that came from the CSV file. And for do that job, we analyzed tools like Apache NiFi, Apache Beam, Luigi, and other commercial ETL platforms. But we chose DBT, the data build tool, to do it. Because it's a SQL-based transformation approach, built-in support for modularity, testing, documentation, and version control. It also has compatibility with Iris InterSystems via community adapter. The DBT enables modules because it's modularity, because it encourages and enforces a declarative model-driven approach and to data transformation, where each transformation is defined and modular for SQL with explicit dependencies. And as data reached the analysis store, we needed to empower end users. So if you remember from the strategic vision, the product business, they wanted to enable end users from naive to business analysts and engineers. So from business analysts to decision makers, with easy and secure access via tools like Power BI, Tableau, Click, and others. And we had 3 options. And from those 3 options, we chose all of them. Direct database access we use for custom queries and technical scripts for our own use. Or N for Jasper reports and InterSystems reports. The REST API goes for integration with external systems and also enables MCP clients to connect to our data platform using JSON RPC. And MCP clients will enable AI agents to talk and execute features on our platform. As a third option, at the same time, and as next steps, we choose adaptive analytics by enabling the semantic layer and modeling, integrated security, and we hope if it's enabled in the next version, the multi-tenancy support. So as soon as it enables multi-tenancy support, next step goes to adaptive analytics to enable semantic modeling. Now, as our data platform was evolving, architecture became more modular and robust, composed of multiple stages. And while data collection and consumption were handled separately, we faced a pressing challenge of doing orchestration, because data pipelines goes with orchestration, right? And we had to ask the question how to orchestrate and schedule executions of transformation process, for instance, especially SQL-based transformations handled by DBT and other dependent pipeline stages. Using orchestration is one way to do pipelines, but we had no need to add more tools to orchestrate. While options here were Apache Airflow, it's on top of the option. If needed, we will use it, but we analyzed that. Also Luigi, Prefect, and Dexter, and we stayed with iris interoperability as a strategic and cost-effective decision, because iris interoperability is already embedded in our production environments as part of our existing software stack, and by using it, we ensure traceability, reliability, and integrability, without increasing the TCO for our customers and for our platform, and without burdening the team with operational overhead, because introducing new technology in that stack without being really needed, the infrastructure team would need to manually install, learn how to do it reliably, that new component. So that's why, if there is no need, don't do it only because the internet's saying that, for instance, a partial flow should do your orchestration. If you don't need it, don't use it. Well, by choosing our interoperability, we align orchestration with our existing operational model. We reduced cost and risk and ensured fast, secure, and maintainable pipeline execution. This decision reinforces our strategy to not evolve efficiently without over-engineering. In summary, each architectural decision was carefully made to balance technical requirements with business requirements and other constraints. The priority was scalability, security, and maintainability. We built a flexible and robust data platform, and for example, if you wanted to deliver real value with AI, you must provide quality data, right? So this product is about data platform, is about data, but AI is about data, right? AI isn't better than the data it gets. It simply amplifies whatever it's given. So data is very important to AI and language models. Our choices ensure that the platform can evolve with confidence, support multiple clients, and deliver real value through data. Thank you. Any questions?